Hello there, Mr. Sutton here, bringing you the BC Calculus 516 Part 2 homework solutions on integration by partial fractions. On this problem, I'm trying to integrate this fractional function here. And now I notice that I've got unique linear terms in the denominator, and there's no other way to get rid of those or simplify this. So I'm going to try integrating by partial fractions. I'm going to take this initial fraction, which I'm calling 1 over x minus 1x plus 3, and I'm splitting that up into a over x minus 1 plus b over x plus 3. Next, I'm going to multiply this whole equation by x minus 1, x plus 3. So that cancels out my denominator completely on the left, leaving me with just 1 over there. On the right side, we've got the x minus 1's canceling, so I have a times this leftover x plus 3. And then over here, the x plus 3's cancel, leaving me with b times x minus 1. Next, I'm going to pick some convenient x values that'll get rid of a or b so I can solve for the other one. So I'm going to get rid of b first. I'm going to pick an x value of 1 to zero that out. So then I've got 1 equals, and now I just have this a term. We have a times 1 plus 4, or 4a. Dividing both sides by 4, I have a equals 1/4. Next, I'm going to pick something that gets rid of the a here, like negative 3. So if I plug negative 3 in for x, I still have the 1 on the left side. The a term is completely gone now, zeroed out. Over here, we've got b times negative 3 minus 1. So that's negative 4b that 1 equals. And then if I divide, we have b equals negative 1/4. Now I'm going to substitute these back in up here so I can actually split up this fraction inside my integrand. So I'm going to rewrite this as 1/4 over x minus 1 minus 1/4 over x plus 3. And now I can actually go term by term and take the antiderivative using ln. So for this first one, I've got 1/4 ln absolute value of x minus 1. Next, I have minus 1/4 ln absolute value of x plus 3. And don't forget your plus c. Now looking at my answer choices, this doesn't match any of them because it looks like they actually simplified using some log rules. So to simplify all this together, I'm going to factor out this 1/4 from these two logarithmic terms, and then I'm just doing ln minus ln. If I'm subtracting logs, I can combine them by dividing the things that are inside. So I can write this when the dust settles as 1/4 times ln of x minus 1 over x plus 3. Still have that plus c there. So that looks like it's going to match answer choice A. For this problem, I'm trying to integrate this rational function. Now, this is one that it doesn't look like I can really simplify. You can factor a little bit in the numerator, but not in a way that's going to let you cancel anything out. So since I've got these unique linear factors in my denominator, I'm going to use integration by partial fractions on this one. So I'm going to take my original fraction here, and I'm going to split that up into a over 2x minus 1 plus b over x plus 1. Next, I'm going to multiply everything by this denominator over here, 2x minus 1 times x plus 1. That gives me x minus 10 on the left. On the right side, the 2x minus 1 cancels out completely, leaving me with just a times x plus 1. And then I have x plus 1's canceling, so b times the 2x minus 1. Next, it's time to pick a convenient value of x that's going to get rid of each of these letters here. I'm going to get rid of b first so I can solve for the a here. So to get rid of b, I need to have a value of, let's see, if I add 1 divided by 2, that'll be 1/2. I need to plug in for x to do that. So if x equals 1/2, let's see what my equation looks like. Over here, I've got 8 times 1/2, which is 4, minus 10 gives me negative 6. And then b gets canceled out completely because we're just multiplying b by 0. But we have a times 1/2 plus 1, so that's going to be 3/2 a. And then to solve for a, if I multiply by 2, that's negative 12. Divide by 3, that's negative 4. All right, let's solve for the b value now. To do that, I need to get rid of a by plugging in the x value negative 1. So if I do that, over here on the left side of my equation, I've got negative 8 minus 10, which is negative 18. And over here, I've got, let's see, negative 2 minus 1, so that's b times negative 3. Dividing by negative 3, I get a b value of 6. All right, now I'm going to actually go ahead and rewrite these fractions in my integrand. So I'm going to have negative 4 over 2x minus 1 plus 6 over x plus 1 with the dx there. And now I'm going to use ln to take the antiderivative of these. So for my first term, I would have normally negative 4 times ln absolute value of 2x minus 1. But since my linear function here has a tail that's not 1, since the derivative of this is 2, I'm actually going to have to divide this by 2. So this is going to be negative 2 ln absolute value of 2x minus 1. Again, inside function, tail of 2. Over here, though, I don't have that issue. The derivative of this linear function is just 1, so this is just going to be 6 ln absolute value of x plus 1 plus c. And looking at my answer choices, I've got my answer right here in choice B. Notice in choice A, they had that one for those of you who forgot to divide by the 2 because of this 2x in here. But choice B is what we want here. On this problem, I'm trying to integrate this rational function, and it doesn't look like I can really simplify this in any way. So I'm going to try integration by partial fractions then. I'm going to see if I can factor this denominator. So things that multiply to 10 and add up to negative 7, we've got x minus 2 and x minus 5. And I'm going to split this up and try to rewrite this as a over x minus 2 plus b over x minus 5. This is my partial fraction trick I'm doing here. All right, now I have to find a and b, so I'm going to multiply everything by x minus 2 times x minus 5. That gives me 1 over here on the left. And on the right, the x minus 2's are canceling, leaving me with a times x minus 5. And then the x minus 5's cancel, leaving me with b times x minus 2. Next, we're going to pick some values of x that will let us solve for a and b. So to solve for a, I'm going to let x equal 2, because that's going to cancel out this b term over here, doing b times 2 minus 2. So then if I plug in 2, I get the equation 1 equals, and then this is a times 2 minus 5, or negative 3, so negative 3a. So then dividing by negative 3, I get an a value of negative 1/3. Now to solve for b, I have to get rid of the a term. So to do that, I'm going to plug in the x value 5. That's going to give me 1 equals b times 5 minus 2, or 3b. So then dividing by 3, we have b equals 1/3. Plugging those back in now for a and b so I can actually split up my fraction. I've got negative 1/3 x minus 2, or over x minus 2. And then I have plus 1/3 over x minus 5. Now to take some antiderivatives. So for this first one, this is going to be negative 1/3 ln absolute value of x minus 2 plus 1/3 ln absolute value of x minus 3 plus c. And is that any of the answer choices? Doesn't look like it. It looks like they actually simplified their answer choices with log rules. So to do that simplifying process here, I'm going to yank this 1/3 out, kind of factor it out of these two logarithmic terms. And then I end up with, we've got a negative ln of x minus 2 and a positive ln of x plus 5. If you have a negative log, that actually, and you combine it with another log, that ends up in the denominator of a fraction. So you could think of this as being like ln of x minus 5 minus ln of x minus 2. And if I put those together in one ln, I'm going to then have ln of x minus 5 in the numerator. And if I'm subtracting, I actually am dividing by the thing inside. So this is going to be an x minus 2 in the denominator. And I still have that plus c. So that's going to give me answer choice E. On this problem, I'm trying to take the integral of this rational function. Now, this is one where you might be thinking, well, maybe I can use some substitution. But if you take the derivative of this denominator here, you're not going to get something that's going to cleanly cancel out with this 3x plus 1. I mean, you'll have 2x minus 2, but that isn't quite going to do it. So our other tactic then is to try to use partial fractions. So I'm going to take this and factor the denominator to see if I can get some unique linear factors. And if I do that, I end up with x minus 1 and x minus 3 in that denominator. Since these are different, I can use my easy partial fractions antiderivative process. So we're going to split this up into a over x minus 1 plus b over x minus 3. Next, I'm going to multiply both sides of my equation by this factored denominator here, x minus 1 and x minus 3, that completely cancels out the denominator on the left side. So that's just 3x plus 1 over there. On the right side, the x minus 1s are going to cancel. So I'm going to have a times that other thing I was multiplying by, the x minus 3. And over in this next fraction, the x minus 3's cancel, leaving me with b times x minus 1. Now I have to find a and b. I'm going to pick a value of x that lets me find each one. To find a, I need to get rid of b, so I'm going to pick an x value of 1 to plug in. If I plug in 1 for x in this equation, on the left side, that's going to be 3 times 1 plus 1, so 4. On the right side, the b value cancels out, so we just have a times, we're plugging in 1, so 1 minus 3 is negative 2, so negative 2a. Dividing, we get a equals negative 2. Next, I need to get rid of the a value to find b, so I'm going to pick an x value of 3, and plugging that in, on the left side, 3 times 3 plus 1 is 10. On the right side, a is gone, and we have b times 3 minus 1, or 2, so 2b. Dividing by 2, we get b equals 5. Awesome. Now we got to plug these back in. So this is going to be negative 2 over x minus 1 in my integrand now, plus 5 over x minus 3 dx. Going term by term and taking my antiderivative, this is going to be negative 2 ln absolute value of x minus 1 plus 5 ln absolute value of x minus 3 plus c. And let's see if we can match that with one of the answer choices. So negative 2, nope, not quite. We need negative 2 times ln of x minus 1. That's the wrong stuff inside. I'm looking down a little further, though. I see that they really just wrote what I had here in a different order. So we have the 5 ln of x minus 3. We have the minus 2 ln of x minus 1. We have the plus c. So choice D, then, is the one we want. On this problem, I want the definite integral from 0 to 1 of this rational function. Now, this is one we're just going to quickly check to see if substitution would help us out here. If I take the derivative of this denominator, will that give me something that cancels out my numerator? Not really. We'll have 2x plus 3, so that's not going to help. So then my next recourse is to use partial fractions, try factoring this denominator, and write this as two different fractions. So to start that process, I need to factor my denominator. I'm going to have x plus 1 and x plus 2 down there. And then I'm going to rewrite this. I'm going to split this up into a over x plus 1 plus b over x plus 2. Next, I'm going to multiply everything by this x plus 1, x plus 2 to get rid of the fractions. So that gives me just 5x plus 8 on the left. On the right side, I've got, let's see, x plus 1s are canceling, so a times the x plus 2 that's left over. And these x plus 2s are canceling, so that's b times the remaining x plus 1. Now to find a and b. So I'm going to pick a value that's going to get rid of the b first here. So if x equals negative 1, on the left side, if I plug in negative 1, that's negative 5 plus 8, which is 3. And b is gone. This is just b times 0. But for a, we've got negative 1 plus 2, which is just positive 1. So 1a equals 3. So we can just say a equals 3 and don't have to do any more work on that one. All right, for the next one, I want to find the b value. So that means I need to get rid of this a term. I'm going to do that by picking an x value of negative 2. Plugging that in on the left, we have 5 times negative 2 plus 8. That's negative 10 plus 8, or negative 2. And over here, the a's are gone now. A is gone. We just have b times negative 2 plus 1, or negative b. Well, if negative 2 equals negative b, then b must be positive 2. So now that I have my a and my b, I can plug those back in and split up this fraction inside the integrand. So I'm going to write 3 over x plus 1 inside my integral here, and then plus 2, that's my b value, 2 over x plus 2, put my little dx over there. Now to take the antiderivative, so I've got 3 ln absolute value of x plus 1, and that I'm going to add 2 ln absolute value of x plus 2, and we're evaluating that from 0 to 1. So plugging all this in. Now you could merge these together first. I'm just going to plug stuff in right away though. So we're going to have all this stuff with 1 plugged in. And I'm actually going to simplify a little bit just to save space. So I've got 3 ln of 1 plus 1, or 3 ln of 2. Then I've got 2 ln of 1 plus 3, so 2 ln of 3. Minus, now I have to plug 0 into both of these. So that's going to be 3 ln of 1. And I'm also going to have in this same kind of bracket here 2 ln of 2. Let's keep going now. At this point, you might have noticed the answer choices are pretty small, right? I mean, they've, at least in terms of number of terms, there's only one term, or this divergent thing over here, which means that you get like ln of 0 or something that you can't actually do when you're trying to plug things in. So we need to simplify our logs. This is going to be a bit of a process. I'm going to do this first bracket first. So when I have a coefficient outside, I can pop that in as an exponent. And then if I'm adding logs together, I can multiply the stuff inside. So I've got 2 to the third, and I've also got 3 to the second, and those are being multiplied by each other inside one big log now. So ln of 2 to the third and times 3 to the second. Over here, ln of 1 is just 0, so that's gone, but I'm still subtracting 2 ln of 2, so I can write that as minus ln of 2 squared. And I'm popping in these exponents because, among other reasons, you'll notice none of the answer choices have coefficients on your logs. Everything is inside. All right, if I'm subtracting logs, that means I'm allowed to divide by whatever was inside. So this is really ln of all this stuff divided by 2 squared. Well, what is this stuff on the left side? We've got 8 times 9, which is 72. We're dividing essentially by 4 then. And 72 divided by 4. That's going to end up being, let's see, that's going to be like a little bit less than 20 because 80 divided by 4 is 20, so that ends up being 18, ln of 18. And that is an answer choice, choice C.